All right, 8-7 is L'Hôpital's rule. It looks like hospital, but with no S. So it's called L'Hôpital, all right? And basically, this is 8.7, which I just erased. Fantastic. All right. And this says if f and g are differentiable on an open interval, AB, and it contains c, and the derivative of g is not 0, then the limit as x approaches this c, all right, of f of x over g of x could be the derivative. So basically what it says in Marashio terms is take the derivative of the top and the derivative of the bottom. And you can keep doing that as long as you have an indeterminate form. This indeterminate form is 0 over 0, infinity over infinity, 0 times infinity, okay? Those are all indeterminate forms. So let's do a problem. Easy stuff. Okay, so if I have this problem, I want to make sure I could use L'Hôpital's rule. So when I put in negative infinity, of course, I get infinity over, looks like infinity really. So I get an indeterminate form. So L'Hôpital's is okay. I can use it. That's important because if it's not an indeterminate form, you can't use L'Hôpital's rule. So we brought back limits a little bit. So all I do is take the derivative of the top, x going to negative infinity. Derivative of top is 2x. Derivative of bottom, remember derivative of bottom, we learned that little trick. Okay? That is still an indeterminate form, so I'll keep going. So I'll get limit as x approaches negative infinity, and I'll take the derivative of the top, derivative of the bottom. Okay? Remember that this guy really comes upstairs. So this is the same as the limit of 2x goes to negative infinity of 2 over e to the x, or I should say 2e to the x, which when I plug in negative infinity, actually, my bad. I'm going to leave it in the bottom. And now I'm just going to replace. My bad. I screwed this up. So now just replace with negative infinity. If this is going to negative infinity, this guy is getting very, very large. That's small. This guy equals 0. Remember, that's going to infinity or negative infinity. That's going to 2. That's staying 2. That's 0. Done. It's easy. Okay? Let's look at another one. We'll be done with this in 5 minutes. Look at this one. We can do this 2 different ways. We can do it one way we learned back in the day, the limit as x approaches negative 1 was to be the factor. So if I factor the top, it factors to 2x minus 3 times the quantity x plus 1. And this becomes x plus 1 on the bottom, or it is. Those cancel out. You plug in negative 1 and you get negative 5. You remember that? Back in the day. All right, September. So now, instead, we're going to try and use this the factor way. We're going to use L'Hôpital's rule here. L'Hôpital, let's make sure we can use it. We get 0 on the bottom and we get 0 on the top. It's okay to use L'Hôpital's rule. So let's try it out. L'Hôpital's rule says take derivatives. Limit as x goes to negative 1 of 4x minus 1 all over 1. Well, 4x minus 1, check it out. When I plug in negative 1, because now I'm not going to continue because I don't have an indeterminate form. That's why I stopped when it was 2 over the e to the x. That's not indeterminate. All right? This is not indeterminate anymore. This is negative 5. Boom, whichever way you like to do it. Perfect. That's L'Hôpital's rule. And you're saying, why didn't we learn this back when we were doing this? Because I like to torture you. Come on. Look at this one. As it goes to infinity, I got infinity over infinity. Let's not do it in red. Let's do it in a different color. Yes, yes. Yes, yes. Let's do nice, and do it. This is infinity over infinity. So L'Hôpital's, we can use it. That's okay. So now, let's take derivative top, derivative bottom, limit as x goes to infinity. That is the same thing as just 1 over x. As I take this to infinity, this guy goes to 0, the answer is 0. Remember, things to remember when these come up, if they have the same power and the coefficient, then it's the coefficients, top heavy, bottom heavy, all that stuff applies. Here's some problems to try. You got 4 problems to try tonight. This is the quickest video of calculus you'll ever see. Every kid loves L'Hopital's rule, and they always remember it because it looks like a hospital. Okay, it sounds like hospital. So enjoy L'Hopital's rule.